Hi everyone, I'm Gareth Bowker and I'm Head of Security Research at Jscrambler. Thank you for being here at the Supply Chain Security Summit. Just to let you know, this is a live session, so you've got an opportunity to ask questions as we go. Where I can, I'll answer them as we're going through the presentation, and there may be a few minutes as well at the end for questions too, so please do use that Q&A facility if you like. So in this session, we're diving into a significant shift that's underway in the software security world. A couple of months ago, in January, OWASP released their 2025 Top 10 update, and it sent a clear message. Supply chain security has moved from a secondary concern to the defining challenge of our time, at least as far as web security is concerned. The OWASP community voted software supply chain failures into their top 3. And that's something that didn't happen in a vacuum. And over the next 30 minutes or so, we're going to explore what that shift actually means for your organizations. I'm going to share some new research findings with you, and I'm going to walk through a practical framework that you can use to defend against these threats. Now, this isn't just theoretical. Supply chain risk is running client-side right now, and we need to talk about how to protect it. So let's begin. So to start with, I just want to unpack why this OWASP signal matters more than it did in their previous updates. So the numbers tell the story. Software supply chain failures received 106 first-place votes out of 212 respondents in the 2025 Top 10 ballot. Now, that's not just a number. That is the broadest consensus that voting in the OWASP Top 10 has ever seen. When you look at the full voting data, it's actually even more striking. Virtually every respondent ranked supply chain failures in their top 3. So this wasn't just incremental, it was directional or a mandate. For years, supply chain vulnerabilities were treated as a secondary concern, something that you fix as you patched your own systems. But what OWASP is doing is they're reframing the problem. It's not just, let's also worry about dependencies. It's dependencies are the problem. So the community isn't just acknowledging supply chain risk anymore. They're saying it's the biggest risk in application security right now. And that kind of consensus doesn't happen because of just one breach or one CVE. It happens when practitioners across every industry recognize they're facing a systemic problem that existing frameworks haven't adequately addressed. So let me walk you through the evolution of how OWASP has framed this risk, because the naming matters. We start back in 2017. The top 10 listed using components with known vulnerabilities. That was how they defined it. The assumption was straightforward. Patch your dependencies, stay on top of CVEs, and you're secure. That was the hygiene model. In 2021, we moved to vulnerable and outdated components. So the conversation had shifted. It wasn't just about patching known vulnerabilities anymore. It was about managing the full life cycle of dependencies, staying current, dealing with technical debt. Here's where the 2025 Top 10 breaks ground. Software supply chain failures. This is fundamentally different. The naming change signals a philosophical change from manage your dependencies better to the problem is systemic. And the scope has expanded dramatically. It's not just about what's in your node modules or your Maven central repository. It's about what happens when those components arrive in your application, how they execute in the browser or on your servers, what security controls surround them, and how attackers can manipulate the supply chain itself. So supply chain is no longer a patching problem, it's an execution problem. It's about runtime exposure, about understanding that every dependency is a potential attack surface that needs active monitoring and threat modeling. And that's what makes the OWASP 2025 Top 10 fundamentally different. So let's ground this in reality with 4 recent examples, and they show the evolution of supply chain attacks. So first, if we go back to 2020, it was SolarWinds. And here, attackers compromised the build pipeline itself. They injected malicious code into the software build, and that then got distributed to 18,000 organizations. It happened upstream in the factory, if you will. Next is XE-utils. Now, this one's particularly chilling because it involved years of social engineering. Starting in 2022, an attacker using the alias Jiatan spent about 2 years making legitimate contributions to the XE-utils project. And at the same time, there were some sock puppet accounts that were pressuring the original maintainer into granting Jiatan co-maintainer status. Once they had that commit access, they smuggled in an obfuscated backdoor that targeted SSH authentication. And the social engineering campaign here took years, but even after the backdoor shipped, it took weeks before a Microsoft engineer noticed some unusual CPU usage and traced it back to the compromised library. Next is polyfill.io, and this one's a different kind of scary, if you like. So attackers here didn't hack the infrastructure, they just bought it. The company acquired the polyfill.io domain and GitHub account outright. Over 100,000 websites were pulling what they thought was a legitimate polyfill library, but the new owners here started serving malicious JavaScript through it. The original author warned everyone to remove it immediately, but by then the code was already running across the web. And most recently here was LottyPlayer. So this is the one that really demonstrates how mature these attacks are becoming. So LottyPlayer here is a widely used animation library with tens of thousands of weekly NPM downloads. And in October 2024, attackers phished a maintainer's NPM credentials and used that access to publish a compromised version of the package. So sites that were pulling the tainted update, it had a crypto wallet drainer that was injected into their pages. It prompted visitors to connect their wallets, and then it siphoned the funds. Now, the attack window was only a few hours before it was caught, but the damage was immediate. Now, there are plenty of others that I could talk about here too. The Bybit wallet theft that stole $1.5 billion, or the Shai Hulud NPM worm. And this was the first self-propagating supply chain attack against the NPM ecosystem. But what matters in each case here is the attack chain ends in the browser session. So the evolution goes from compromising the build pipeline to manipulating maintainer trust, to acquiring infrastructure, to hijacking package credentials at scale. Each one of these is progressively harder to detect, but they all converge on the same endpoint, and that is malicious code executing where the users are. So if you look at this conveyor belt, this is, I think, how most people think about building software. So code comes in at the start there from source control. It goes through a build process. Now, this could be manual. It could be part of an automated CI/CD pipeline. It gets tested. It gets deployed. And then it's done. Software's shipped. This mental model is comfortable. It suggests that your application is a finished product. Once you've tested it, once you've security scanned it, once you've shipped it, you know what's running. That's the story that the conveyor belt here tells. I think this model has held up pretty well since the time that I was at university. And even with the early web applications, it wasn't that far off the mark. But here's the problem. That story is incomplete. Modern web applications don't quite work this way, not anymore. Because composition doesn't end at deployment. It continues. And it continues in an environment where you've got very little visibility and very little control. So in the next slide, we're going to pull back the curtain a bit, and we're going to see what that finished product, where it actually lands. We're going to see what really happens when your application runs in the real world. So keep this conveyor belt in mind as we move forward, because we're about to show you how it extends beyond where most teams think it ends. This is the reality. That conveyor belt, it doesn't end at deployment. Your application lands in the browser, and it immediately becomes a collection point. The moment that page loads, it starts pulling in external JavaScript from everywhere, frankly. You'll see analytics scripts, you'll see marketing pixels, chat widgets, CDN-hosted scripts, AI chatbots, fraud detection systems, A/B testing frameworks, consent managers, and that list goes on and on. Even if you tested all of these scripts in your test phase, they're not static. Those vendors can, and they do, update their scripts all the time. If you're using tag managers, the situation is even harder to manage. Your marketing team could add a new script to your deployed web application at any point after deployment. And the traditional process of application testing won't catch those changes either. So let's put some numbers around this. 92% of web pages load third-party resources. On e-commerce sites, 50% of all JavaScript comes from third parties. But I think what's really important to highlight is these scripts load additional scripts dynamically. Their behavior changes based on geography, user segments, the time of day, or whatever parameters you can imagine. And as I just talked about, marketing teams may well bypass your AppSec team entirely. They add pixels and trackers through tag managers without any kind of security review. Nobody sees them. Consent manager loads 12 or 15 scripts automatically. An AI chatbot transmits user data in real time. And none of this was tested in CI/CD. None of this was in your traditional threat model. This isn't just a security problem, though it absolutely is one. It's a visibility problem, and it's a governance problem. You don't control runtime behavior the same way that you control infrastructure. Your CI/CD pipeline only covers part of what's actually running. And the browser is where that composition continues uncontrolled. And that is your supply chain now. I'm sure some of you might be thinking at this point, well, we've got an SBOM, so a software bill of materials. We track our dependencies, so we should be covered. And to be clear, SBOMs are genuinely valuable. They answer a really important question, which is what was included at build time. But there are certain things that an SBOM can't tell you. It can't tell you what is executing right now in your users' browsers. It can't tell you what changed at runtime, because those scripts that are loaded from CDNs can be updated by their third-party owners without any change to your code base. It can't tell you what data those scripts can access, and it can't tell you which scripts loaded conditionally based on geography or user type or session state. And it certainly can't tell you what AI services are being invoked dynamically by third-party components. SBOMs are really useful at telling you the build time story, but they can't tell you about the runtime story. And I've got a couple of examples of that now. So at Jscrambler, part of what our research team does is to analyze what is actually executing on production websites. So this is the real client-side supply chain. And this is a recent example here. We actually just published some research on this just a few hours ago this morning. And check out the blog on our website if you want to see more details on this. What we found, though, really should concern every CISO here. We were looking into data collection by third-party pixels, the types of things that advertising and social media companies use to track users around the web. We looked at major e-commerce merchants, some household names, top 500 global retailers. And we looked on their payment pages, and we found there several instances of advertising pixels. So TikTok and Meta in this case. And they were receiving the personal data, things like names and addresses, purchase details, as well as the last 4 digits of payment card numbers. Think about that for a moment. An ad tracking pixel on a payment page is exfiltrating partial card data to a social media platform. This isn't malicious injection. This is a legitimate marketing script doing basically what it was meant to do, just in a context that nobody in the security team realized it was operating in. There's another example. There's a different major merchant that we looked at, again on a payment page, and there we found metapixels transmitting user details like the postcode, the zip code, before the cookie consent banner had even been interacted with. So the user just hadn't consented to anything, but data was already flowing to a third party. Another merchant that we spoke to just earlier this week told us that they had everything set to hash customer data, and a pixel script had added a new feature that they weren't aware of. As a consequence of that, it was acting outside of the bounds of what they expected, and it began sending unprotected address data to a social media company. It was completely against everything that they thought that they had set up in their configuration. They ended up reporting this issue to that social media platform as a privacy incident too. But think about this in the context of our traditional build cycle model. Would you ever detect this data leak? How would you go about detecting an oversight or a change to a third-party configuration or a third-party script update, well after your web application build has been deployed? Think about what I just showed you on the previous slide too. Those advertising pixels, they might never appear in an SBOM. They were added after deployment through Google Tag Manager by a marketing team. They're unlikely to be in your package.json. They're not in your build manifest. They probably don't exist in your dependency graph, but they are executing on your payment pages, accessing sensitive data and transmitting it to third parties. So build time visibility does not equal runtime control. That is the gap. Your SBOM covers the left side of that conveyor belt that we looked at, but everything happening on the right side in the browser is invisible to it. And that's where the data exposure is actually occurring. That's the shift beyond traditional threats that I want to emphasize. We're not just talking about malicious actors anymore. Legitimate, well-known scripts from major platforms are operating with broader data access than organizations realize. And that can change without you ever knowing about it. This is governance exposure. It's not just security exposure. And this is what we're actively investigating across the industry right now. PCI DSS is probably the closest thing that the industry has to a widespread security standard. So when they introduced requirement 643 in version 4 of their standard a few years ago, they were responding to a real threat that they were seeing in the wild. Requirement 643 says that organizations must maintain an inventory of all of the different scripts on their payment pages, and they all need to be authorized. So not checked annually, authorized pretty much as they're added. That's pretty prescriptive. And then requirement 1161 takes it further. You need change detection for script behavior on those pages. So the PCI Council recognized something that Jscrambler has been saying for years. If you can't see what's executing on the client in the web browser, you can't maintain the integrity of that page. Or in the case of PCI, you can't maintain the integrity of a payment transaction. Now, PCI's scope is pretty narrow. Their focus is on securing payment pages. But OWASP's 2025 top 10 has now elevated supply chain security to number 3 globally. And they're saying the same principle applies to your entire application surface. That's 2 independent, separate bodies, 2 different perspectives, same conclusion. And I think when 2 different security worlds align like that, it's a signal, not noise. It means the threat is real, the attack surface is material, and organizations need to act. So here's where supply chain security gets even more urgent. AI is no longer just running in the cloud or deployed on servers behind your firewall. It's increasingly running client-side. Think about it. Chatbots are embedded into web applications. There are personalization engines that segment users in real time. There are fraud detection widgets that talk to your backend, analytics engines processing user behavior. All of those components execute in the browser. And when they execute in the browser, they have the same access as any third-party script that we discussed earlier. They can see the website's DOM. They can see and access form fields. They can read cookies and local storage. They can make arbitrary network requests. Most AI governance frameworks today assume cloud or server deployment, guardrails, model versioning, API gating. But those frameworks break down when the AI component is running on the client. A CISO facing this has to ask 3 questions. So first, what data is actually accessible at runtime in the user's browser to this component? Second, can we restrict its behavior, or does it run with unrestricted DOM access? And third, can we shield sensitive fields so that they're invisible to client-side code? And if you can't answer those questions today, then you have work to do. Now, this is the operational shift. 3 things CISOs need to prioritize now. First is continuous client-side inventory. So not a quarterly audit of deployed libraries, saying a live, continuously updated view of what's executing in your users' browsers right now. What scripts are active? What AI components? What APIs are they calling? That inventory, it needs to be granular. It needs the version, it needs the behavior levels, because a supply chain attack can easily hide in a minor version bump. Second is runtime behavioral monitoring. You need to detect when code behaves differently than expected. If a script suddenly starts exfiltrating form data, you want to catch it in seconds, not weeks or months. If an AI component starts making calls to unusual endpoints, you want an alert ASAP. And third here is granular data access control. Can you prevent scripts from accessing credit card fields? Can you isolate sensitive DOM elements? Can you enforce which code can call which APIs? This is where you move from visibility to control. But here's the hard truth. Most organizations today have invested enormously in infrastructure observability. You've got Kubernetes logging, you've got cloud API audit trails, you've got network flow data, but your visibility into the browser is nearly 0. If we have more visibility into Kubernetes than we do into our customers' browsers, then we've profoundly misallocated our security resources. The browser is the new frontier, and that rebalancing needs to start today. So here is a key truth. Supply chain security doesn't end at deployment. It ends where the code executes and where the data is created. That's where the real risk lives. And that's the last mile that we need to secure. If you're serious about supply chain security, you need to care about both sides of that conveyor belt, the build pipeline and the runtime environment. You need visibility into what's actually running in production, what data is flowing through your code, and whether it's going where it should. Jscrambler has been researching this for years. We found real attacks, real data exposure, real business impact, and we've built solutions that actually work. So please visit our booth and we can show you how to get started securing the last mile of your supply chain. So thank you very much for your time. I'm available afterwards for any questions, or if you have any questions now, please do put them into the chat. We have a booth in the exhibit hall as well, or you can reach out using the contact details on the screen. You can also subscribe to our newsletter, or feel free to connect with me on LinkedIn. And I look forward to continuing the conversation. I'll just give it a few seconds to see if we have any questions. Otherwise, I'll give you a few minutes back before the next presentation. Okay, well, it looks like the Q&A is silent, so thank you again, and I welcome you to visit the booth shortly. Thanks very much, everyone.